Hello and welcome. In this test feature, I'm highlighting how to select the right app for a given problem. Obviously, solving a problem requires a detailed knowledge of thermodynamics covered chapters 2 to 3 in this textbook. Some of the questions you ask when you simplify a problem is that, is the system open or closed? Is it a steady system or unsteady system? Is unsteady? Does it go from a beginning state to a final state, etc., etc.? And I just want to show you that how similar this task is when you solve a problem using test. Okay, so I have already logged in as a student, and let me go to the TESTApp module and look at how we go and pick a particular. First of all, as you move your pointer over any node, for instance, open system, you'll find the definition of an open system will appear on the screen, a very short definition to remind you what it means. At every level, whenever you put your pointer, it will give you a little schematic and what kind of problems this particular node of this tree handles. But just to make sure that I make a point that how parallel this is to a manual problem solving. First of all, if you are after properties, then go to this branch, and system means it's a closed system where you find the properties, and here is a flow. These are two kinds of, these are building blocks. You must know how to solve this kind of problem before how to find properties before you analyze a system. Obviously, the basic tools are also linked from the home page. And now, the main analysis is done in system analysis, and obviously closed and open, as we do in a manual solution. If you go through the open branch, you will find the steady versus unsteady. Unsteady going through a process is a special kind of problems. So likewise, as you go through this tree, and you can see that the logic breaks down into whether the system is closed or open, whether it is closed or open, or steady or unsteady. Another division comes with a generic versus specific branch. The specific branch handles domain knowledge. For instance, if I'm looking at open system, the open branch and specific, you will notice that it involves a lot of domain knowledge, like steam power plant or gas power plant, like a gas turbine. Here there is refrigeration, vapor compression cycle, gas refrigeration. Here is air conditioning. So it's kind of self-explanatory how you find a particular class of apps to solve the problem. As the last step, you go and, for instance, okay, let me go and, for instance, you want to evaluate properties. Then at the last step, you select the model, and suppose you pick the perfect gas model. Notice that you end up in a hands-on example page, and that's where you can easily find a nice video or a short video of how to find properties, etc. in this particular case. But just suppose you are not sure. Another way to make sure that you got the right app is, suppose you're trying to solve a refrigeration problem. You're not sure whether to go to closed steady cycles or here. So one way is that you go here and launch the app, and look, instead of looking at the video, just look at the test code, and the test code will kind of tell you what app was used. So in other words, you get some idea that if you made the right choice or not by looking at an example problem, which are always the first page when you click on an app. So it's important to make sure that you are on the right app for that particular problem you're trying to solve.